Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi.
Oi! So they give access to their job portal, Geeks for Geeks, for free?
Yes, complimentary with the course.
And you got your job through that?
Me and 15,000 others across the world.
No way!
Oh, yes, Wiz. Don't delay. Enroll now.
Geeks learning together.
Yeah, so hello everyone. Am I properly audible and visible? Can you please confirm in the chat box so that we can begin? And I would kindly request you to please write down your name in the chat box to confirm your presence. Yeah, hello everyone. So, which one of you guys are here? Yeah, hello Gourav, how are you? And where are other people? Where is Sumit and where are others? Hello Vaibhav. A very good evening to everyone present here. So let's wait for a minute or so and then we can very quickly start. And let me share my screen as well. Yeah, hello Sagar. How are you, Sagar? Yeah, so let us start then. And before we begin with our discussion related to the topic in hand, let me tell more about this series. So, this is the Graph and Tree series. So, this is the GFG practice channel. Yeah, so this is the graph and tree series, and today we are almost at session number 8. Okay, so previously we had around 7 sessions, and we had discussed a lot of topics which include how to represent graph, various travel algorithms like traversal algorithms like BFS and DFS. Then we also learned about multi-source BFS, 01 BFS, and meanwhile we also had a lot of practice sessions as well in between. And apart from that, we discussed about topological sorting as well, and then we discussed about Scan's algorithm. Then we discussed about how to detect cycle in a graph using BFS, DFS, and the topological sorting as well. So these are the topics that we have done, and this graph and tree series are mostly interview focused. So what we are trying to do, we are trying to cover the concepts related to the various important topics of graph and tree, and we are trying to solve the famous interview questions as well. Okay, so the topics for today will be understanding the minimum spanning tree, and we will also be looking into a famous algorithm called Prim's algorithm, which is used to find the minimum spanning tree. Okay, so these are the two topics that we will study today, and these two topics are also one of the most important topics from interview point of view. Okay, So let's see how many of you are here. Okay, we have 6 people with me right now. That's great. Okay, yeah. So, and one more thing is that Geeks for Geeks, the official YouTube channel, is hosting a series of interviews called the Winter Interview Preparation. And you will find a link in the chat box to basically understand what exactly this is, and you can take part in it. And we will also be having sessions over Zoom as well. And on 24th of December, our CEO, Mr. Sandeep Jain, will be live on Zoom, and it's basically an Ask Me Anything session, and which you can get an exclusive entry as well to that Zoom session in which you can ask him anything. Okay, so kindly check out the link in the description for the winter interview preparation. Okay, apart from that, I would also request everyone to kindly have a look at the Geeks for Geeks self-paced course available on the website. And it's one of the very great and well-crafted course if you want to learn data structures and algorithm. Okay, so this is about it. So let's begin then. Okay, so okay, let us start then. Yeah. So, how many of you all already have an idea about what exactly is minimum spanning tree? Okay, can you please write a small description about minimum spanning tree? Okay, I'm really sorry about that. I just missed my audio device. It was switched off. Sorry, this is happening quite a lot in a lot of sessions. Really sorry about that. So let me just tell the approach again once again. No worries. Okay. So you can see that in the screen. Okay. So am I properly audible right now? Can you please give a confirmation? Yeah, thank you, Gaurav. Okay, thank you, Vaibhav. Okay, so what I was trying to explain is the concept of minimum spanning tree. Yeah, so first of all, what exactly is minimum spanning tree? Let us say we have been given any graph. Okay, so by any graph, I means we have been given a graph which consists of n nodes and let's say m edges. Okay, so now the thing is that we have to construct a tree from the given graph such that if you are summing up all the edge weights, then that will be minimum across all possible configuration that may be possible. Okay, so first of all, it should be a tree. Now we know that if a graph has n nodes, then it should have n minus one edges in case it is a tree. So in the given example, as you can see, I have drawn out a graph. This graph contains 5 nodes and this graph has 6 edges. Okay. So but if I want to convert this graph into a tree, it should contain 4 edges. Okay. So why 4 edges? Because 5 minus 1 is equal to 4. Now we have to delete 2 edges. So the question is, can I delete any 2 edges? Let's say I want to minimize the sum. Okay. So it makes sense that let me delete the those edges which has the highest number of sums. So for example, 8 and 7, let's say. Okay, so if I will delete 8 and 7, I may get a minimum spanning tree, but it's not like that I can delete any two edges. For example, if you delete the edges, let's say 6 and 2, in that case what will happen, the node number 0 will become an isolated node. Okay, it will no longer be connected to the graph, so it means that it is no longer a tree. So we don't want that. Okay, so we have to delete our edges our in such a fashion that after the deletion, the graph gets converted to a tree. The first important point. And the next important point is that the sum of all the edges should become minimum. Okay, when you sum up the weights of the all the edges, it should become minimum. Okay, so this is the concept of minimum spanning tree. Now, can anyone of you tell me that is it possible to have to construct multiple spanning trees? I'm not talking about minimum. Let me say, is it possible to construct multiple spanning trees, only spanning trees? Is it possible? See, so basically what is happening here, you have to delete you have to make n minus 1 edges somehow. Okay, so what you can do, you can just delete away the extra edges. You don't care about the weight right now. So in that case, what is happening is that multiple spanning trees are possible. Okay, so multiple spanning trees are possible in that case. Okay, and out of all the multiple spanning trees, you have to select those spanning trees which gives the weight as minimum. Okay, now tell me, are multiple minimum spanning trees possible? Okay, now saying out of all the spanning trees, you select those spanning trees which has the minimum weight. So can we tell this from tell it in a very guaranteed way that there will be only one minimum spanning tree? Can anyone tell me? Or there can be multiple possible minimum spanning tree. I'm talking about minimum spanning tree. Okay. No, yes. Yes, Gaurav, you are correct. Yeah. So basically, what is there? Even if we are constructing a minimum spanning tree, the minimum spanning tree may be multiple minimum spanning trees. Okay, this will depend upon how the edge weight are distributed. For example, let's say if I'm adding, let's say 5, so I can say 1 plus 2 plus 2 is 5. Okay, this is also 5, and let's say in that 1 plus 1 plus 3 can also be 5. Okay, so in this fashion, there are two ways to represent the sum of 5 by 3 nodes. Okay, so we can either take the edge which gives me 1 1 3, or we can either take 1 2 2. Okay, in both the cases there are ways, okay, to construct a minimum sum. So since there are multiple ways to construct the same sum, we can basically generate multiple minimum spanning tree. It may or may not be possible. Okay, but we cannot state for surety that we will always have one unique chemistry. I hope this is clear to everyone. Okay, so let us move to the next part. Next part is devising an algorithm which will help us convert a given spanning tree into minimum spanning tree. Okay. For example, I have already drawn a graph here. Okay. So as you can see in this graph, I have drawn basically a graph. Okay. Now in this graph, what you can see here is that how many edges do we have? So we got around 5, 0, 1, 2, 3, 4, 5, and 6. So we got around 6 edges. Okay. Now since we got around 6 edges, and yeah, so since we got around 6 edges and we seem to have 6 nodes, okay, and we seem to have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 6 nodes and 9 edges. Okay. So but if it should be a tree, in that case what should we have? We should have 6 edges and 5 6 nodes and 5 edges. Okay. A tree with n nodes should contain m minus 1 edges. In that case, what we have to do, we have to delete few nodes. So as you can see in the whatever I have drawn here. Yeah. So this basically is a minimum spanning tree of this graph. Why? Because since we had 6 nodes, this graph contains 1, 2, 3, 4, and 5 edges. Okay, so it is a tree. And if we sum all of these, I am getting a sum of 17. And there are no possible ways I can basically generate another graph that has that which is a tree and at the same time a sum less than 17. So this is one possible configuration of an MST. Okay, and so this is how and this is just an example. Now we will try to solve this question, try to apply an algorithm to solve this question. Okay, so how many of you all know about Prim's algorithm? Anyone? And apart from Prim's algorithm, are there any other algorithms that will help us to solve the minimum spanning tree problem? Anyone? Can anyone just, if you know Prim's algorithm, can you just describe very briefly what exactly is Prim's algorithm in the chat box? Okay, there is Kruskal's algorithm. Yeah, that is good. And so, what I'm asking is, can you just describe the Prim's algorithm in a very short and brief manner so that we can understand? Anyone? Okay, so can anyone tell me whether Prim's algorithm is a greedy algorithm or not? Okay, so let's continue then. Okay. So the idea of Prim's algorithm is based upon the concept of greedy algorithm. So what we try to do is that we start from a given node and then we try to look into its adjacent nodes. Okay. So let's say if I have a node number 0, I will try to look at the neighboring nodes and I see a node number 1 and node number 2. I note down the weight of each of those nodes. Okay. And then what I see, I try to look at the minimum possible value. Okay. In that case. And then I go to that node. And when I go to again that node, I basically try to traverse the adjacent nodes of that particular node and try to again calculate the minimum. Okay. And then what we do basically is that we try to include them in our MST as well. Okay. And why MST? Whatever minimum we are basically taking, we will include it in our MST. Okay. And after we have visited all the nodes, and it means that we have only taken those nodes which are giving minimum at every point of time. And finally, after the entire traversal gets over, we can basically obtain our MST. Okay. And we can also return our sum as well. So this is the concept of finding the minimum spanning tree with the help of Prim's algorithm. Okay. Now I will be showing you how to dry run on this. What are the data structures that we need to solve this? Okay. So let me just once again give you a clarity about it. Hmm. Yeah. So can you tell me what are the data structures that we will need to implement this? So let me just describe the intuition. The intuition of this algorithm is a greedy technique used for every node. Okay, for every node we are, yeah. So for every node we are trying to apply the greedy technique. Now, what exactly we are observing is that for every node, we are greedily selecting its unvisited adjacent node with the minimum edge weight. Okay, the important thing is it should be unvisited also. Okay, for example, let's say if you're standing on this node and there are various other nodes. Okay, it may happen that the minimum weight the adjacent node is already visited. So in that case, you are not supposed to take that node because that node is already visited and it is already there in my minimum spanning tree. Okay, the thing is that in my minimum spanning tree, I should include all the nodes. Okay, that is the reason we are greedily applying the greedy technique on each and every node. Then we will visit the adjacent node which is unvisited and has the minimum edge weight. Okay, and how we will make sure that we are always taking the minimum edge weight. Which data structure will help us get that? Okay, you have to tell me this. And after that, what we are doing, after we do so for every node, we can get the sum of all the edge weight of the minimum spanning tree and the spanning tree itself. Okay, so we can get both. Okay, so yeah, so this is a concept. Okay, now I will do a dry run so that you all understand it. Yeah, so let us look into a dry run approach for this. So let me draw a graph first. Okay, and after I draw a graph, I will basically do a dry run. Okay, so let me just draw a graph then. Okay, let's say this is node number 0 and this is node number 1, this is node number 2, this is node number 3, and let's say this is node number 4. Okay, so these are connected by edges. Okay, so let's say this is not connected like this. Let's say it is connected like this. Okay, let's say it has got weights also. So let me say this is 2, this is 3, this is 5, this is 7, this is 8, and this is 6. Okay, so this is how the graph is. Okay, so code will they be saying that we will use a priority queue. Okay, and why exactly priority queue? Can you tell me? And which type of priority queue? Tell me that. Which type of priority queue should we use? Anyone? Okay, so yeah, so the thing here is that we will be using the min heap. Okay, why min heap? As I just described that. Yeah, so why exactly min heap? Because as I just described that what happens in a min heap is that whatever element which is of the smallest value will always come on the top. Okay, that is the meaning of the priority queue, and by default a priority queue of the max heap type. So we have to convert a given priority queue into min heap type by following its correct syntaxes. Okay, so what will happen here, whenever we are inserting any node with its weight, whichever node which has the minimum weight will come at the top. Okay, so because we are applying the greedy strategy on each and every node, and we want only those adjacent nodes which are unvisited and which basically has the minimum edge weight. Okay, so if that is how we will get that, we'll only get that if we are using a priority queue. Okay, and in what format we will insert in our priority queue? It is weight comma node. Okay, so the first term will be our weight and the second term will be our node. Okay, so for example, let's say if we are initially standing at the node number 0, so node number 0 I will so I will push inside the queue. Okay, but the sum will also be 0 because the weight of the node number 0 is not connected to any other nodes. Okay, so the edge weight is 0. But now if I will start moving from node number 0 to its adjacent node, so then I will start counting the edge number 0. Okay, so initially we will be putting 0 comma 0 inside our priority queue. Okay, this is also similar to a BFS. In BFS also we try to take a queue, we try to we try to insert the source inside the queue, then we try to take that source out from the queue, then go across the adjacent node. So the traversal concept remains the same while we are applying a Prim's algorithm. Okay, so this is the concept about Prim's algorithm. And let me see the chat box. Okay, many heap type. Yeah, so code with they be are correct. Okay, so yeah, so let's move to the next part. Yeah, so I was saying this is my priority queue. Now initially what will happen inside my queue, I will store the value 0 comma 0. Okay, Now what will I do? I will also maintain a visited array. Why a visited array? Because I need to make sure I'm keeping a track of all the nodes I am visiting. So for example, this is node number 0, 1, 2, 3, 4, 0, I think 5. Okay, 0, 1, 2, 3, 4. So there are 5 nodes only. So initially we are visiting node number 0. Okay. So now what we are doing? Okay, and we are pushing that inside our priority queue. So it is done. Okay, so just a minute. Yeah. Now what we will do, we will also maintain a sum equal to 0. So this will help us basically calculate the sum. Okay. So and I'm showing you the question that we will do. So we have a question on the GFG platform itself, which try helps which is basically asking that we are given a graph, and we have to convert it in minimum spanning tree, and we have to return the minimum sum possible. Okay. So in that case, we have to keep a variable sum which will keep adding up as we are building our minimum spanning tree, and after the entire minimum spanning tree gets built, so we will be returning that sum because that is the minimum sum. Okay, so let's see that. So we keep a sum equal to 0, which will be our answer finally. Okay, now what do? We try to run a loop, basically try to run a loop with the condition that PQ is not empty. As long as PQ is not empty, we will keep on running our loop. So we take the top element from our priority queue. Initially the top element will only be this. Now what we do? We remove that element. Okay, so we are taking a priority queue and we are removing that element. Okay, so now we have to explore all the nodes which are at the adjacent of 0. So I see that node number 1 and node number 3 are adjacent at 0. Okay, so in that case, what will happen? Since I have node number 1 and node number 3 in adjacent of 0, so first it will check whether node number, so the node that I am considering, is it visited or not visited? Okay, so till now I have not marked anything as visited. So what will I do? I will mark node number 0 as visited. Okay, so let me mark visited as red pen. Okay, so node number 0 is visited now. Okay, I have marked node number 0 is visited. So every time I'm processing a node, if it is not visited, I will mark it at visited. Okay, now, what will happen if it is visited? Can anyone tell me? So, yeah. So basically, if it is visited, it means that it is already a part of our MST. Okay, because I have already made it visited because that node is already traversed and I have already applied my greedy technique on that. It is a part of my MST now. Okay, so if it is visited, I will not do anything. Okay, I will just again go to the next iteration. Okay, so this is it. Now I mark this as visited. Okay, now what I do, I just add the sum also. Okay, so basically now I add the sum. So sum is equal to 0, no problem. Now I go to the adjacent node 1 and 3. Now what I do, the first adjacent node is 1 and its weight is equal to 2. Okay, I make it. Now I see whether node number 1 is visited or not visited. I see it is not visited. Then what I do, I push this value inside my queue. So in what format I am pushing, does anyone remember? Okay, so in what format I am pushing? I am pushing it from in the form of weight comma node. So the weight is 2 and node is 1. Okay, so this is the new entry inside our priority queue. And what we will do? Our one iteration is over. Now we will again go back to the same iteration. Now we try to take the yeah, but 1 minute. Okay, I have another element called 3. Okay, so what will it do? This will basically put 6 comma 3 inside of my priority queue because these are the two elements. Now I am done with 0. Okay, remember one thing. I have not marked any of the node 2, neither 1 or not 3 as visited, but I have stored them inside my queue. Okay, I will only mark them visited when I am considering it into my MST. Okay, otherwise I will not mark them visited. Now what will I do? So this is done. Now I will again go to the top element of the queue. I see since this has a weight minimum, so this will be my top element. So I go to node number 1. Okay. Now I go to node number 1 and I try to go to its adjacent element. I see 3 is one adjacent element. I see 0 is one adjacent element. I see 2 is one adjacent element. Okay. So there are 3 adjacent elements. Okay. So what will I do now here is that I will try to go across for 0. But I see 0 is already visited. Okay. So I won't matter it. Now I try to go across 3. So I see 3 is not yet visited. So what will I do? I will mark 3 as visited. And then what will I do? I will mark 3 as visited and then I will try to so basically this was 2 initially. Just a minute, a small error here. So I will not mark this 3 as visited. I am considering 2 right now. I am considering node number 2. So I'm marking node number 1 as visited. Sorry, yeah, node number 1 as visited. Okay, because I took the top element from the queue, I marked it as visited, and I have added my sum. Now my sum has become equal to 2. Okay, my sum has become equal to 2 now. Okay, this is done. Now I will explore all the edges to the node number 1. Okay, now I see node number 3 is there, node number 0 is there, and node number 2 is there. Okay, so in that case, what will I do? I will see which one is not visited. Okay, so neither node number all at 0 is visited, so I will not consider that. Now I consider node number 3. It is not visited. So node number 3 is there, and in that I will also calculate the sum. Okay, so node number 3 is sum of 8 plus 2. So 2 plus 2, so it will become 8. 8 comma 3. Okay, 8 comma 3 will become. Now what will I do? I will go to its neighboring element 2. I see the edge weight is equal to 3. So now I will insert 3 comma 2 inside my priority queue. So I'm done with this. So 2 will get removed from the priority queue now. Okay, so 2 is done. Okay, so I hope everyone is understanding me what I'm trying to say. So now I have processed the node number 2. Now what should I process? I will process a new node. Now I will process the top element from this queue. I see the top element is 3 comma 2 because this is of the minimum weight. Okay. Now what I do here is that I mark node number 3 as visited. Okay. Node number 2 as visited. Okay. I mark it as visited. Now I try to go across all possible nodes. I try to go to 4. I try to go to 1. But 1 is already visited, so no worries. Okay. So in that case, I will try to go to 4. And what will I do? Insert the number 7 comma 4 inside my priority queue. Okay, so this is done, and there are no possible ways, so I just come out. Again I try to take the top element. The top element now is equal to 6 comma 3. Okay, so node number yeah, now it takes see whether 3 is visited or not visited. I see 3 is not yet visited, so I mark 3 as visited and try to go across its adjacent. I see 0 and 1, they're already visited, so no problem now. Okay, I'm done. And meanwhile what I'm doing here, I'm also taking care of the sum as well. Okay, so in this case, I took the sum as equal to 3. Okay, so 2 plus 3 will become basically 5 now. Okay, before I am entering into the loop. Okay, so now, yeah. Yeah, so this is done. So this 3 will also get removed from a priority queue. Now, whatever element is there of the minimum value, I see element number 6 is there. So node number 3 is there. I go to node number 3. I see all nodes are visited. Okay. So in that case, what I do? I just do nothing. I just come back. Okay. Now I see I go to the remaining nodes. After 6, what is there? 7. So I see node number 7 with node number 4. I go to node number 4. I try to visit 1 and 2. But what is happening here? They are already visited. Okay. So in that node, I do nothing. But since I visited node number 4, I will try to add 7 to my answer. Okay, so 7 plus 5 will become 12 now. Okay, so now finally node number 4 is also processed. And finally I come to node number 3. So when I come to node number 3, I see the value 8 there. But node 3 is already visited, so I will just skip over that also. So it is done. So finally what I see here is that my MST is 12. And what is the actual answer here? This one, 6 plus 2, 8. Okay, and yeah, 6 plus 2, 8 plus 3 plus 7. Okay, so 1, 2, 3, 4. So we got 4 edges and 5 nodes. Okay, and we this will be the minimum possible. Okay, so I hope everyone understood it. So our graph would look something like this. This is 0, this is 3, this is 1, this is 2, and this is 4. Okay, and this node has a value of 6, this node has a value of 2, and this node has a value of 3, this node has a value of 5, but that is not a part of our MST. Okay, so let me rub that. But this node has a value of 7. Okay, so this is my MST. 7 plus 3, 10. So 6 plus 2, 8. 8 plus 2, 2, and then 2 plus 6, 8. And after that, we are adding 3, 9, 10, 11. And 11 plus 7 will be equal to 18. So answer is 18. Okay, I hope everyone got it. Okay, so is there any doubts in this? So let us look into the code implementation of our concept. Okay, so I have already shared the Geeks for Geeks practice problem on your screen, and I'm sharing the link as well in the chat box. Okay, so this is a link. Okay, so this is a practice question link that on the GFG portal. So what exactly is this? So the first thing is that we have been given a weighted graph, undirected and connected graph of V vertices and E edges. Okay, and we have to find the MST. We have to find the sum of the weights of the edges of the minimum spanning tree. In this case, we just want to return the sum. So this is exactly what we are doing. We are initially marking a visited array. We are pushing the values 0, 0 into our priority queue. Okay, because we are starting from node number 0. And we are also initializing sum as 0. After that, what we are trying to do is that we are running a while loop. And as long as the while loop is not empty, we will take the top element from our priority queue. Okay, it's the node number and the weight. Now I'm checking whether that is visited or not visited. If it was already visited, I just do a continue. But if it was not visited, in that case, what I do, I mark it as visited. Okay. Now once I mark it as visited, I just add the sum. Okay, whatever sum basically has the weight. Okay, from the priority queue. Then I try to go across all its adjacent node, and then I see whether that node is visited or not visited. If it is not visited, I will push it into the priority queue, because if it is not visited, it means it is not a part of my MST now. So let's push it back into the priority queue. And again, the minimum will come on the top and I will process that. So this is how we are able to apply the greedy strategy on each and every nodes. And finally, after this entire operation is done, we will return our sum. Okay, so let us submit this problem and check whether it is correct or not. Meanwhile, if you have any doubts, you can ask in the chat box. Complexity. Okay, we will discuss the complexity. Just a minute. So as you can see that all the test cases are passed. Okay. So complexity will be, we are using a priority queue, which uses a min heap data structure. Okay, the first thing. And basically, yeah. And what will be the maximum size of the priority queue? Can anyone tell me? The maximum size of the priority queue will be BFS with PQ. No, it won't be VFS with PQ. Why? Because before we are trying to traverse all of our adjacent node, we are checking whether it is visited or not visited. So this step we do not do in BFS. Okay. So what we do in BFS, as long as we are entering into a node, we mark it as visited. But we are only marking it as visited but when we see it is visited, we're not trying to cover its. See, that is the most important part. Okay. Whenever we are including inside our MST, at that point only we are trying to mark it as visited. Okay, so this is the concept. Now Shivanshu was asking about complexity. Okay, so Shivanshu, tell me, we are using a priority queue. Okay, now what is the maximum number of elements that we can insert in a priority queue, that it is getting inserted? Okay, so tell me. Yeah. So basically what is happening here is that we are inserting a total of E edges inside our priority queue. Now priority queue uses the data structure of min heap. Okay. So min heap basically does what? It tries to put the minimum element at top of the priority queue. And whenever we are adding a new element, the entire min heap gets rearranged itself in log E time. Okay. So it will take a logarithmic of time. Since the maximum possible elements inside our priority queue is E, so the time complexity for our priority queue operation is E log E. Okay. This is done. Now after that, what we are doing, we are also using a loop. Okay, while loop. Okay, and there is a pop operation also. Okay, now this while loop will also be running E times. Okay, why E times? Because there can be a maximum of E elements inside our edges. Now we are using a pop operation. Now pop operation takes a logarithmic time. We are basically popping the top element from our priority queue. So that operation also takes a log E time. So again, a complexity of E log E. Okay, so till now we had a complexity of 2 times E log E. This is done. Now, this is the entire operation that we are basically doing. We are running a while loop and we are doing this min heap traversal of a priority queue. So the total time complexity becomes E log E. Okay, I hope everyone understood it. Why the time complexity is E log E, where E is a number of edges. Now let's talk about space complexity. So tell me, what are the spaces we are taking? We are taking a visited array. Okay. The space of complexity of the visited array will be big O of V, because V is the number of nodes. Okay. Because we have to mark each and every node as visited, because we want to include them in our MST. Okay. Apart from that, what else are we taking? We are taking a priority queue also. Okay. So and what will be the maximum size of the priority queues? The priority queue will also take some space, right? So the maximum time of the space of the priority queue will also be O of E. because at max E edges will be inserted into my priority queue. So the space complexity becomes big O of V plus E. The time complexity is big O of E log E. Okay, I hope everyone understood it. So Sivanshu, any doubts? So Sivanshu, did you understand the concept of time complexity? Okay, welcome Shivanshu. Okay, so yeah, so we are almost done with our session. So today we discussed about priority queue, and yeah, so let me tell you that more about this session then. So I've already told in the beginning. So this is for the new students who have joined. So we are conducting a graph and tree session. This will go on for the entire month of December as well in the month of January. Okay. So till now we were meeting every alternate day at 10 p.m. But we will be seeing a change in schedule next week because next week we have got holidays. Okay. And yeah. And again in December we will be studying about tree series as well. And at the same time we will be doing a lot of practice sessions as well. Okay, and this will involve all the important concepts which are very frequently asked in interview point of view, and all the famous interview questions as well. So this is about the graph and tree series. Apart from that, a winter interview preparation series is also going on in the YouTube channel of Geeks for Geeks. You can see a lot of guest lectures which are being planned every day, and yeah, so Gaurav is saying more questions on minimum spanning tree. Gaurav, we won't be doing more questions today. I have kept it for the practice sessions. Okay. So in practice session, we will be trying to cover up concepts which involve both minimum spanning tree and BFS and DFS traversal, connected components, mixed concepts type. Okay. So that is the reason I am trying to keep the session short. And apart from that, yeah, I would request everyone to check the link in the description, which basically contains information about the winter interview preparation. And on 24th of December, there is a session on Zoom with our CEO, Mr. Sandeep Jain, in which you can basically ask him anything. This is an ask me anything type of session. Okay, and you can read the instructions inside in the link, how to take part and how can you get the exclusive Zoom interview invite. Okay, so this is it about the winter interview preparation and about my graph and tree series. Okay, so very thank you for everyone who joined in this session, and I hope you are working hard for your internships and placements. Okay, so I would request everyone to kindly like the session, please. Those all of you are there, kindly like this session and subscribe to the Geeks for Geeks practice YouTube channel, because we have planned a lot of important things right now, because since I am doing a graph and tree series, and in some days you will see a deep dynamic programming series will also start, which will be again focused upon interviews. Okay, so if you are regularly visiting our channel and going across its videos, so this will help in your upcoming internship and placements preparations. Okay, so this is it from my side, and thank you very much. Okay, so a very good night to everyone. Bye bye.